let's do practice problem number 10 on page 284. Here's the problem. Number 10. It's right here. Zoom in on it. And it says well, this is 1 times 10 to the 2 is 100. 100 grams of aluminum block at 100 degrees Celsius is placed in 100 grams of water at 10 degrees Celsius. The final temperature of the mixture is 25 degrees Celsius. What is the specific heat of aluminum? And so we got the problem set up right here. And let me zoom back out. So here's, I just drew a little container of water, and it's at 100 grams at 10 degrees Celsius, and here's 100 grams of aluminum at T initial and T final and so on. All right, so let's solve. So the heat is going to flow out of the aluminum into the water until they both reach the same temperature. And then it's in thermal equilibrium. There's not going to be any more change. So the heat that leaves the aluminum plus the heat that enters the water, that's going to be equal to 0. So the heat of the aluminum equals negative heat of the water. Now what is this? This is MC delta T for the aluminum. This is going to be equal to MC delta T for the water. Now the nice thing about, here's what we can do. Here's what we can do. The mass of the water equals the mass of the aluminum, right? They're both 100 grams. So what does that allow me to do? So I'm just going to call that M. So I'm going to divide by 100 grams, so that the mass goes away. Now what are we trying to find? The specific heat of the aluminum. So the specific heat of the aluminum is going to be equal to, oh, I canceled out the mass here, the specific heat of water times the change in temperature of the water divided by the change in temperature of the, oh, and I need that negative sign, the change in temperature of the aluminum. So the specific heat of water, what is that? Is it 4,180? So this is going to be negative 4,180 joules per kilogram degrees Celsius times, now what is the change in temperature of the water? Well, it's T final minus T initial for the water. T final, what is T final? 25 degrees Celsius. What was T initial for the water? 10 degrees Celsius. And then, now, for the aluminum, delta T was what? Well, T final was 25 degrees Celsius minus what was the initial temperature? 100 degrees Celsius. So I just gotta get the calculator and do all that, and I'll have the specific heat of aluminum. So let's see, let's do the 25 minus 10, that's pretty easy, that's 15. Divided by, now what's 25 minus 100? That's negative 75. So divided by negative, 15 divided by negative 75 equals negative 0.2. And then this is times negative 4,180. And I get 836. And notice the negative from 25 minus 100 cancels with the negative out here. And then the degrees Celsius cancels over here. So that just leaves these units. And that's how you do that problem. Yes?
Can you explain why the heat of the water is negative?
Oh. So what, in other words, why is this negative over here?
Yeah.
Well, remember what Q stands for. Q stands for the flow of thermal energy, heat. And since this is basically sealed off from the outside world, in other words, we're not going to have any heat flowing out or into this system from the outside world. It's all contained, okay? Like you put this in an ice chest, so heat can't get in or out from the outside world. So if the aluminum block, well, look here's what's it. Heat is going to flow out of the aluminum and into the water. Does that make sense? Okay. So the heat that flows out of the aluminum plus the heat that flows into the water, well, all of the heat that flows out of the aluminum is going to flow into the water. So the heat from the aluminum plus the heat into the water equals 0. When I add up the heats, I get 0. Does that make sense why it's equal to 0? Because you're not adding, there's no net change in thermal energy in our system. We're taking energy out of the hot aluminum, putting it into the cool water to get something kind of lukewarm. So therefore this is true. And therefore if I put, look, it says, really I could put the negative on either side. But the heat out of the aluminum is going to be equal to the heat into the water. So they're, so that, yeah.
Is the negative true for all of these type of problems?
Well, if you put heat into something, we call that positive heat. If heat flows out of something, we call that negative heat. And really, see, this is saying, hey, the heat from the aluminum is equal to the heat of the water, but negative. Negative. Because the heat flowing out of the aluminum, it's flowing out. So that's why we have that negative there. The heat of the aluminum is flowing out, but it's equal to the heat that's flowing into the water. So they're going to be opposite sign. See, they have to be opposite. Like, I don't know what the exact values are, but let's say here, this is like 100 joules, and this would be negative 100 joules. So that when I add them together, I get 0. Okay, I tried. I hope that makes sense.
So when you're adding heat, then they'll be positive.
Right.
Heat is flowing away from something.
And look at, let's look at MC delta T for the water. What is the delta T for the water? Well, it ended up at 25 minus 10. See, that's positive, isn't it? That's a positive change in temperature. Look at the change in temperature for the aluminum. It started off, or ends up at 25, but it started off at 100. So it lost 75 degrees, and that's negative. Okay. That is all. That is. Thank you.